The data science process. According to Saltz, most data science processes focus on the tasks that need to be completed in data science, such as the techniques to acquire and analyze data. Saltz analyzed different data science approaches and found that most outline the steps as data acquisition, cleansing, transformation, integration, modeling, analysis, and deployment. The data science approaches are task-oriented, and no real evolution of the process had occurred since the cross-industry standard process for data mining, CRISP-DM, was introduced in the 1990s. The most commonly used data mining process is CRISP-DM, which is a process that conceptually describes the stages used in data mining. Originally created to support data mining projects, it has been adapted by data scientists. There are 6 stages in the CRISP-DM process which are presented sequentially, but iteration is expected. Business understanding, data understanding, data preparation, modeling, evaluation, deployment. Business understanding, data understanding, data preparation, modeling, evaluation, deployment. The start of the process, business understanding, focuses on the business value of the project. Once requirements and objectives are understood, the problem definition is created. Data science projects start with a problem to be addressed or a question to be explored. Tools to support identifying the problem include diagrams such as a decision model such as a fishbone diagram. Once the problem to be addressed is identified, the next focus is on data source identification and collection. Data source identification includes identifying the sources, such as a transactional processing system, and the attributes needed to address the problem. Problems may involve several different data sources, which means data integration work is likely. After integration, data is profiled and statistically analyzed to determine quality, demographics, relationships between variables, and distribution. The outcome of data understanding is a definition of how the data can be used. The data understanding stage is often referred to as exploratory data analysis, EDA. The goal of data preparation is to create the data that is to be used in the modeling stage. Input from data understanding is used to determine the final set of attributes, often referred to as features that will be used in the model. Preparation includes integration, cleansing, and deriving of new attributes. Data preparation is iterative as the training and testing of the model may require new or changed data. The result of data preparation is the data set to be used as input into the modeling stage. As part of the modeling stage, different techniques and algorithms are used to determine the best model. Modeling goes through cycles of testing and training, where the data scientist adjusts parameters to produce the best outcomes. It may be necessary to return to data understanding and preparation stages if the model performance is not acceptable. Model evaluation is determined based on the overall fit to the problem statement and business objectives. Evaluation is conducted by analyzing error rates, variance, and bias of the model. Often models using different techniques are compared to determine the best performing one. Once the best performing model is identified, a formal review is conducted to move to model deployment. The deployment stage is often overlooked and unplanned but important, as this is where business value is realized. Deployment focuses on a working software model that can be supported and executed on a regular frequency. Once deployed, models are monitored for performance, as model accuracy will degrade because of organizational change in time. Models are often retrained once this occurs. The description provided of CRISP-DM is a summary and does not highlight the granularity of effort needed for successful data science outcomes. Many organizations use CRISP-DM as a framework and add steps to each stage for software development teams to follow. There was an effort to create CRISP-DM 2.0 in 2007, but there is no new research or activity in this area.